Hello there. So in this video, we're going to be doing the second practice problem in 7.3 about fiscal policy. And so it's really just kind of going around those multipliers that we looked at earlier and kind of doing a little bit of practice with those. So this is the question of saying, would the multiplier, and this could be the spending or the taxes multiplier, it would be the true for either one, would it be larger or smaller if households saved more of their income, right? So if they got an increase in their income and instead of saving 200, they saved 500. So think about just kind of in your head, if they're not spending as much money, right? And that means the next round of spending is not going to be as large. And so then that means the next round of spending won't be as large, right? So each time there's going to be less spending in the system. So we would say that the multiplier should be smaller, right? Because they're spending less each and every single time. The second one, would the multiplier be if they saved all of an increase in their income? So let's actually kind of think about, well, let's say I gave you change in disposable income, I gave you $1,000 increase. And for change in savings, so this is the MPS, right? And we know that 1 over the MPS is the spending multiplier. And so it's the reciprocal. If I said that you saved all of it, right? So here, right, this would be 1. And so 1 over 1, the spending multiplier would be equal to 1. Now, this, you might think to yourself, well, then there's still some multiplying. No, there's not. Because you'd say, let's say there's an increase in investment spending of 50 billion times 1 means aggregate demand goes up by 50 billion. And so there isn't any multiplying effect. The more savings that there is, there's less of that multiplying. And actually, there's a name for this. It's called the Paradox of Thrift. And in fact, it was something that Keynes observed as well. So again, Keynes a big deal guy, John Maynard Keynes. But his observation about the paradox of thrift is that you want people to be thrifty. You want them to save, but at the same time, you don't want them to save too much. Because if they save too much, then the whole economy can grind to a halt really quickly, and we don't get this multiplying effect. What would be the multiplier if every household spent all of an increase in their income? Well, let's kind of rerun our numbers here. And let's say MPS. And so instead, right, they had their $1,000 increase and they had 0 here, right? So 0 divided by 1,000 is equal to 0. And now this is going to make a weird number for us. We know the spending multiplier is 1 over MPS. So if we said 1 over 0, well, you can't divide by 0, so it's undefined. So mathematically, we cannot define it, but we know what it would be if you reason this out a little bit for a moment. If I spent all 1,000, and then you spent all 1,000, and then John spent all 1,000, and then Bobby spent all 1,000, and then Lauren spent all 1,000. It's an infinite increase in aggregate demand. Right? So, thinking about the multiplier would be infinite in that sense. And so if we had an increase of, investment spending of 50 times infinity would be an infinite increase in aggregate demand. We obviously know that that's not something that actually happens, but this is kind of testing our knowledge a little bit. Now, let's go ahead and write out our multiplier table. And this is actually just practice in converting some of these numbers into multipliers. And I've given you basically the only piece of knowledge you need is one of these two, and you should be able to do the rest. So if you know that the MPC is 0.9, you know MPS is 0.1. And we know that this is 1 over the MPS, and this is 1 minus 1 over the MPS. So in fact, you really only need one piece of information to do these. 1 over 0.1 is 10, and this one is -9. Now, the way that I remember to do it, and I mentioned this very quickly at the last video, was actually not 1 minus 1 over MPS. That's too hard for my brain. Right? I can't remember that formula, and I don't think you need to. If you just remember the spending multiplier and the tax multiplier is 1 less than the spending multiplier, and the sign is inverted. That's to me the easiest way, but your mileage may vary. And then sometimes the taxes multiplier is actually given as an absolute value as well. So sometimes you don't even have to remember that there's a negative sign. The trouble is if you forget that negative sign, you will forget the effect, right? That if taxes go up, that output goes down. And so that's why the sign is flipped there, why they have a negative. Because if taxes go up, then you multiply it by a negative. That means the output value that it generates would be negative. So here we have 0.8, although we don't really need that. And this one, 1 over 0.2 is 5, so -4. 0.25, this one's 4, -3. 0.67, so this is 1 over 0.33, so that's 3, -2. 0.4, right? So 1 over 0.4 is 2.5. Sorry, had a brain fart. So negative 1.5. 0.5 to 0.5, so that's just 2. So that one's negative 1. And then this one's 0.67. 1 over 2/3 is 1.33. I'm going to actually double check that because I think that that sounds wrong. So that's negative 0.3. And then this one, 0.25, 1 over 0.75 is now I'm having a brain fart. Uh-oh, this is embarrassing. Well, I said I was going to check the other one anyway, so let's go ahead and check the other one. All right, let's do this here. 1 over 0.67. Yeah. Oh, 1.5. Oh my goodness. You can tell my brain is not on yet today, right? For sure. Embarrassing. Oh my goodness. Mr. G, you're the worst. We already knew that. This is the 1.31. There we go. Negative 3. Now, I will just tell you that out of all of these that we've just kind of made here, you're not going to see problems on a test that typically ask you to generate that one, or that one. You usually will end up with a nice round number for the multiplier. It's usually 10, 5, 4, 3, or 2. And your taxes multiplier is 1 less than that, so it should be bad. Numerical value for the investment government spending multiplier increases as the value of the blank to blank, propensity to blank, blank. So this is saying the spending multiplier goes up as we'd say and there's multiple ways you could answer this. You could say as the MPS goes down, or you could say as the MPC goes up, right? So and I'll just start with the first one. Marginal propensity to save decreases. So basically, as people save less of their money, the spending multiplier goes up. Right? That's kind of the flip of that, is the other way to say it. The government spending multiplier is 5 in Clayton. The tax multiplier is negative 4. And then we get another kind of data table here, the spending multiplier for Clayton. So we're given total consumption and total income on this one. So we can look at it and say change in income is 100, change in consumption is 75. So the change in saving is equal to 25. And so change in saving divided by change in disposable income is our MPS, right? So that's MPS. And so we know 25 over 100 is 0.25. And we know the spending multiplier is 1 over MPS. So 1 over 0.25 equals 4, all right? And so we'd say 4. If there's an increase in taxes, and these problems are not related to each other, I should probably make that clear and maybe just use like a different value or a different name here for Ledoux. How about that? Make it a little better here. Ledoux. If there's an increase in taxes of 200, the decrease in GDP will be, and so let's use this one to do that. If we know the spending multiplier is 4, then the tax multiplier we know is equal to negative 3. And so negative 3 times 200 is the decrease in GDP will be 600. And so it won't be a decrease of negative, right? It's just a decrease in GDP. If we had just said the change in GDP, you would say there's a decrease by 600. If there's an increase in spending of 100 and an increase of taxes by 100, then the change in GDP will be what? Now, this is by far the trickiest, right? And you will see this question on AP. You will see it, and you will see it on my exam. This is very tricky, but it's in fact quite easy if you know what you're doing. So let's kind of start here. If we increase G by 100 and we multiply that by 4, because that's our spending multiplier, increase aggregate demand, 400, okay? At the same time, we increase taxes by 100. We multiply that by negative 3, because taxes go up by 100, so negative 3, so negative 300 AD. So the overall is positive 100. So it does not just cancel itself out, right? The increase in government spending does not just cancel out the increase in taxes. What it has the effect of doing, I'll kind of move this so you can see this, is that the initial change, right, is what we care about. And this is not change GDP. If you just change taxes, that doesn't, the actual change in taxes doesn't change GDP. It's what do people do afterwards that changes the GDP. And the initial over here, though, does change GDP. So when we increase government spending, that immediately goes into GDP, CIGXN. So this initial affects it, this one does not, but then the rest of them cancel each other out. So all the ripples in the pond are canceled out. This would be true for every single type that we look at, that the end number is the 100 is equal to the initial, right? So it's an equal to the initial. We could do this with different multipliers. Let's do it instead with 10 and negative 9, right? So you've got positive 100 times positive 10, right? This is the government spending side. And that's saying, I'm just making up a spending multiplier here, positive 10. And then you'd say, you know, taxes went up by 100 times negative 9. Well, that's 1,000. That's negative 900. So at the end of the day, it's exactly equal to the initial change in government spending or investment spending. And so this could be 200, right? It could be 500. It doesn't even matter what the multiplier is, because we know that the government spending multiplier is one larger than the tax multiplier. So you know that the change in GDP would be 100. You don't need the multipliers to do those, and you won't get them on the test. So you'll think that it's a really tricky question, but it's actually one of the easiest ones to answer. All right, hopefully that helped you. I'll see you next time.